Okay. All right, well, thank you for joining me this morning, having me. Talking about one of my favorite subjects, which is sinkholes. So I've only got 12 minutes. If you want to talk more, catch me out in the lobby, because I could go forever on this subject. Okay, so what do you think about when you hear the term sinkhole or karst? Do you think of, these holes that just, suddenly open up in the ground overnight that tend to eat houses in the middle of the night or eat cars? Here locally, they seem to have an affinity for high-performance sports vehicles. If you're from Kentucky, you understand that reference. So to understand karst, sinkholes, you first have to understand the science behind it, okay? So we're talking about the dissolution of the limestone or the carbonate rock, which, it looks a little bit cumbersome at first, but if explained correctly, it's actually fairly simple, okay? It's simply the carbonic acid eating away the limestone, okay? So that's fairly simple, okay? Now, the actual process of karst forming is a little bit more difficult, okay? Because we're talking now about the complication with the rock mass. You've got the joints, the fissures, the fracture zones, all that, come into play, as well as the groundwater, topography, all these things, okay? So that's a little bit more complicated. Now, trying to explain how a sinkhole forms to someone who has a non-scientific background, particularly in geotechnical engineering or geology, is darn near impossible. It'll leave you pulling your hair out. As you can see, I've given this talk more than once. So we're going to go down the rabbit hole here a little bit and talk about what is not a sinkhole. That's how I start my explanations now with, what is karst, what is sinkholes. I rule out things when I talk to people, okay? So a sinkhole is not a hole in the ground, okay? It's not a random hole. It's not an animal burrow. It's not an uprooted tree, okay? It's a natural geologic process caused by dissolution of the limestone, okay? You've got these fracture zones that are already present. They may or may not be clay filled. They may just be open voids, okay? It is activated by inundation with water or vibrations, usually caused by construction or by just changes in the natural drainage pattern. It could be a change caused by construction that's draining the water toward a certain direction. Okay, so it's not a man-made phenomena, but man can help induce sinkhole formation. So now we're going to talk about a few examples of lessons that I've learned over the years. One is in terms of safety, and it's not safety in the sense of, is a structure going to be safe if you construct it over top of karst topography or sinkholes. I'm talking about your safety while on site with a site that has sinkholes. In this instance, we had it was a transformer pad located near an intersection at a business park located in an area of very intense karst geology. Okay, 2 men from the local power company approached this vault to service it. One of the men stopped the other just short. They looked down, and there's a crescent-shaped opening in front of this vault structure, protruding about 12 to 18 inches. They shine a light down inside of it, and they see that there is a dropout sinkhole feature. This vault is being precariously supported on either side, barely. Have a straight shaft, 5 feet diameter, 16 feet down, okay? The lower 8 to 9 feet of that shaft is jagged rock. Okay, could have been a very dangerous situation. When I saw it with my own eyes and I saw the jagged rock, it reminded me of the scene from Return of the Jedi with when Luke was about to walk the plank with his buddies, okay? Okay. So I think that was episode 6 officially, episode 3. I don't want to start that debate here, but yeah, that could go totally the wrong direction. But anyways, I'm joking about this a little bit, but not to make light of it. It could have been very serious. If the gentleman had fallen, he'd been seriously injured. To retrieve him from the bottom of the hole would have been a massive undertaking. You have to remove the transformer itself, the vault structure, all while maintaining the stability of the sinkhole. So it had been a massive undertaking, and he was very fortunate not to have taken another step forward, okay? So safety is paramount, being aware of your surroundings. I had another project in the same general business park. They were constructing a 1 million square foot building on an 80-acre site. You do the math on that, you realize there's not much wiggle room to move this building around, okay? So we get up there, we do some borings. Refusals generally around 10 feet plus or minus. It's fairly consistent, as consistent as it gets for limestone. We have one boring about 50 feet outside the building line, rocks at 36 feet. So we do more borings. We discover this elliptical shaped, basically buried sink feature. We decide to wait and chase it during construction. Once we get the final design drawings, lo and behold, they move the building footprint over top of it. So now we really have to characterize this thing. So I had my field engineer out there with the construction crew. They're digging it out. And he says, Wes, we found exactly what we thought you were going to find. It's a V-shaped valley. But it's a little bit different than we thought. There was a narrow grike, length of about 100 to 150 feet along the footing line. So that boring ended up catching this 2-foot wide grike and riding it all the way down. So we're starting digging on that, and he says, well, what do we do with this? And I said, well, give me some feedback. What are you seeing? Is the soil inside the grike, is it wet, is it moist, is there any seepage? He said, no, it's bone dry. It's hard as a rock. I said, okay, the best thing we could do then is to cover it up, okay? Just let sleeping dogs lie. Because in this situation, we would have been playing fire to do anything else, okay? Why would we construct like a typical grade A inverted filter and induce water into a feature where there is not currently water, okay? It probably would have been better if we had just not dug the thing up at all. So, replaced the concrete cap, then replaced with compacted soil and moved on. Fairly straightforward fix. So another project I had, most recent, talking the same business park. You see a common theme developing here, okay? Wastewater treatment plant expansion. I was involved in the first phase. I knew that there was a lot of karst features out there. They get out to install the oxidation ditch structure, $14 million worth of concrete. Got to add excavation that's about 25 feet down in the ground, okay? They end up encountering rock in the northwest corner. They were not planning on encountering that. Wes, what do we do? Okay, dig out a couple of feet of rock. We'll put a soil cushion back in. Okay, it'll be okay. A few days goes by. I get a call. Hey, Wes, we've got 3 fissures that have opened up in the ground about 10 to 15 feet apart, and they're in a line. What do we do? I said, okay, not a big deal. They're only a few inches wide. We'll check them out later on. Go ahead, keep ramming out the rest of the rock. We'll see what happens. Worst comes to worst, we can fill them with concrete or slush grout. A few days later, I get another call. This time it's from the resident construction engineer. He goes, Wes, we've got a problem. There's vapor coming out of the hole. So at this point, I knew we had something big going on. There had been a change in the weather the day before actually. It was abnormally warm for that time of year. We're talking late January, early February. And then the weather had switched or was back towards freezing. It was just like an overnight thing, kind of like this time of year. And so I knew that we had a cave structure. It was the temperature differential because caves are typically the same temperature year round. That air was coming out of that fissure and mixing with the colder air outside. And this was the result, okay? So I calmly relayed onto the team that, hey, I've got this. You all don't need to worry. I'll put together a scope, we'll evaluate this thing. So we did a whole series of stuff. We did some geophysics, we did a couple rounds of rock core borings, we did some imagery with a GoPro camera, and the geophysics really didn't show a whole lot. The rock core borings were only able to penetrate the cave at one point. We were kind of shooting in the dark. It was a needle in the haystack. It was hard to find. So, the camera imagery provided some good info, but it did not give us any sense of orientation of the feature, okay? So that created a problem. We needed to do something else. So we ended up utilizing a gyroscope laser scanner. We installed the laser scanner at 3 different entry points, did a total of 4 different scans, and combined into one point cloud model. We found that we had a cave that was 34 feet long, 4 feet wide, and 27 feet deep from the existing ground surface to the deepest part of the cave chamber, okay? Big problem. To make it worse, we now knew the orientation of the feature. It was located right along the footing line, okay? So I thought, my gosh, what are we gonna do here? Do we abandon ship and try to move the site? We really had nowhere to go. Do we put it on deep foundations? Do we fill this full of grout? If we fill it full of grout, where's it gonna go to? And then it dawned on me, maybe the simplest solution is the best one. So I got together with the design team and I asked the structural engineer, worst comes to worst, if the roof of this cave drops out, and we've got about 6 to 9 feet of cave roof below the bottom of the structure, would the structure remain in place? He analyzed it, and the answer was yes. The footing was a sufficient width, it would bridge perfectly over top of the cave. The footing was about 5.5 feet thick, sufficiently rigid. So the best solution here was really no solution at all, okay? So moving on, and really just to summarize, I'd like to say that, when you're out on site, whether you're doing a karst evaluation, whatever, especially in situations where the grass is abnormally high, you have poor visibility, be very careful, take your time, okay? It's very easy for an accident to happen, okay? So just take your time. Another point I'd like to leave you with is, realize when no solution is the best solution. Sometimes it's better to do nothing than to do something, okay? And the last one that I've got for you is, know that sometimes the solution doesn't have to come from you. You just need to lead the horse to water. Thank you.